Hi students, welcome to the ABK Chemistry channel. So today we are going to discuss about one of the important topic regarding for our board examinations as well as competitive examinations. See, what is the name of the topic is integrated rate equation of a zero order reaction. The topic is from Chemical Kinetics chapter 12th portion. Okay, so before going to discuss about this topic, please subscribe the channel and activate the notification bell icon for further updates. Thank you. Come to the discussion. So, integrated rate equation of a zero order reaction. Before going to discuss about this topic, I am giving some fundamentals regarding kinetics. Just listen carefully. If you take one general reaction, that is the reactants will be converted into products. In a general reaction, the reactants are converted into products. How to write rate equation for this reaction? The rate is always directly proportional to the concentration of a reactants. Already you know very well. Rate is directly proportional to concentration of reactants. Okay. Now here rate is equals to proportionality constant. I am taking K here, that is concentration of reactants. So what is K is there? The K is known as a rate constant. It is a rate constant I am taking here. Now how can you write rate of a reaction? This is rate of reaction. How can you write decrease in the concentration of reactants with respect to time or increase in the concentration of products with respect to time? Okay, with respect to reactants I am writing here decrease, that is minus in the concentration of reaction, differential rate equation I am writing here with change in time, small change in time is equals to K into concentration of reactants. What is this equation is there, students? What is this equation is there? That equation is known as a differential rate equation. We can write differential rate equation for any reaction. With respect to reactants I wrote here minus decrease, small change in the concentration of, minus indicates the decrease in concentration of reactants. Okay. Now with respect to time is equals to K into T. See, what is the differential rate equation is there, and this equation does not provide the clear information about a chemical reaction like rate of reaction, order of reaction, like that. Whatever the property is there, that property generally does not described clearly, does not given this equation, differential rate equation generally. So because of this, what we are doing is nothing but to this differential rate equation I am going to doing which one? Integration I am going to doing. Integration rate equation will be give the clear information about rate, about order, about take any property generally. Okay. So just simply one comparison, there is a difference between X-ray scanning and MRI scanning. Just X-ray scanning will does not provide a clear information. It will be give macro level information, not micro level information. But integrated rate equation will be, that is MRI scanning will be gives the very micro level information, micro level. So integrated rate equation is a like MRI scanning, differential rate equation is a like a X-ray scanning. Very simple comparison. Okay. Now come to the, let's start integrated rate equation. So integrated rate equation we are doing for which reaction? Differential rate equation reaction. Student keep in mind. Directly I am going to taking this one as usual I am writing here. So I am erasing this one, students. Now come to the start. First, okay. Now the rate of reaction, generally I am taking the reactants are converted into products in general reaction. What is the rate equation? Rate is directly proportional to concentration of reactants. Now the rate is equals to K into concentration of reactants power 0 I am taking, students. Why? Because it is a zero order reaction. It is also power 0 I am taking here. How can you write differential rate? Decrease in the concentration of reactants with small change in time. Small change in time is equals to K into any power 0 will becomes to 1. This total term will becomes to 1. See, this is the equation what we are getting after next. Okay. Just simply minus dt I am going to sending this side. Minus dt I am going to sending this side. What I am getting here, students? Change in the small change in the concentration of reactants is equals to minus dt, it will be goes this side. So we are getting minus K into dt, minus K into dt. Keep in mind integration on both sides, integration on both sides, integration on both sides. What I am getting here? Integration of small change in the concentration of reactants is equals to minus K into, K is a constant, to the constant don't do integration. Now integrated rate equation of which one? No, dt here. integration, differential gets cancelled. Here also integrated, differential gets cancelled. What is the remaining part here is there? Concentration of reactants is equals to minus K into T plus I am going to adding here. Keep in mind, why I is nothing but when we can do integration, we should have to take one constant plus I. I is equals to what, student, here? Integrated constant, and this I am going to taking as a equation 1. This I am going to taking as a equation 1. See students, I am going to taking at the time is equals to 0. Time is equals to 0. What is the meaning of time is equals to 0? Still the reaction is started. If time is going on, the reactants will be converted into products. Then the concentration of reactants decreases, concentration of products is increases. Time is equals to 0 means still reaction is not started. So what happens? T is equals to 0. That time the concentration of reactants are present how? Initial state, that is 100% reactants as usually there. At time is equals to 0. Substitute T value and concentration of reactants value in equation 1. What is T value? Concentration of reactants value is there. This you have to substitute in equation 1. So what we are getting, students? What we are getting here? Just listen carefully. Now what we are getting here? Now concentration of reactants is there. In this place I am going to substituting which one? Initial concentration. Initial concentration of reactants is equals to minus K into T plus I am going to substituting 0. T plus I am going to substituting 0 plus I is there. Is it or not? Now minus K into 0 becomes to 0. So initial concentration of reactants is equals to I. So this equation I am going to taking as a 2. That is second equation I am going to taking. Okay. Now substitute equation 2 in equation 1. This is equation 2 I am going to substituting in equation 1. I value what is there? Initial concentration of reactants, that I am substituting here. So what I am getting, students, here? Concentration of reactants is equals to minus K into T plus, in the place of I am going to substituting initial concentration of reactants. Minus KT I am sending this side, it will becomes to KT, and this concentration of reactant I am sending that side. So it will becomes to KT is equals to initial concentration of reactants minus, this will because that side, and concentration of reactants it will becomes. K is equals to initial concentration of reactants minus concentration of reactants divided by T will becomes this side T. Okay. Now very important equation, students, very important, so keep in mind. So this is also very important equation. This I am going to taking as a equation 3. This I am going to taking as a equation 4. I mean, what is the integrated rate equation of zero order reaction? K is equals to initial concentration minus final concentration divided by T. At what time? What is the concentration of reactants is there? And this is the initial concentration of reactants. Very important. What are the example for zero order reaction? Very important. Decomposition of ammonia. That is 2 moles of ammonia I am going to taking here. Now the reaction can takes place approximately 1130 Kelvin temperature. The reaction can takes place on platinum catalyst, surface of platinum catalyst. Now we are getting N2 plus 3H2, all are present in gaseous state. Ammonia, nitrogen, hydrogen, all are present in gaseous state. This reaction zero order reaction. That means the rate does not depends on concentration of ammonia. What is zero order reaction? The reaction in which the rate of reaction does not depends. The rate of reaction does not depends on concentration of reactants. The rate will becomes to constant here. See here, the rate of reaction does not depends on ammonia. Depends on surface of catalyst. If surface of the catalyst is more, rate of reaction is also more. Surface of the catalyst is less, rate of reaction is also less. So that means the rate of reaction depends on surface of catalyst. And next, another example, I mean thermal decomposition of hydrogen iodide you have to take. The reaction can takes place in the presence of Rm. Here also the rate of reaction depends on surface of Rm catalyst, decomposition of hydrogen iodide. So it will be gives the H2 plus I2. Keep in mind, students. Very, very important. Very, very important. 100% they will ask examples of this one. Now, coming to the another important part regarding zero order reaction, graphs. Graphs. Number of competitive examinations, board examination, 100%. Represent which of the following graph is correct for zero order reaction or first order reaction, they will ask. Coming to the zero order reaction first. From equation 3 I am taking, students. From equation 3. From equation 3. What is the equation 3 is there, students? Concentration of reactant is equals to minus K into T plus initial concentration of reactants. Is it or not? Now here Y is equals to Mx plus C type is there. Okay. Now I am going to taking a graph. I am going to taking a graph here like this. Now I am taking a little bit bigger, I mean sizes. Okay. Now I am going to taking like this. Okay. Graph I am going to taking here. Now on y-axis I am going to taking which one? Concentration of reactants. Concentration. Is it or not? Or I will write in the form of word form. Concentration. Concentration of which one, students? Reactants. Concentration of reactants. On x-axis I am taking which one? Time I am going to taking here. X-axis time I am going to taking here. And the slope is which slope? M is slope here. Minus K. Minus is nothing but negative slope we are getting here. Negative slope. And this is what? This is intercept. What is the intercept is there, students? C is the intercept. Intercept means which cuts the y-axis. This is x-axis and this is y-axis. On y-axis what I am taking? Concentration of reactants. And this is intercept, initial concentration of reactants. And I am going to getting which one? A negative slope. Slope is negative here. Slope is negative. And slope is equals to minus K. For a numerical point of view, very, very important. If you take concentration of reactants with respect to time, slope is negative. Slope is negative. Like that you have to take. If for example, I am going to taking this one. See 1 minute here. Here rate, what is the rate is equals to concentration of ammonia, rate is equals to K into, I am sorry, rate is equals to K into concentration of ammonia power 0 I am taking. Any power 0 I am going to taking, what happens, students? 1. And that means rate is equals to K. K is a constant. For example, I will take another graph here. Now like this. Now here like this. On y-axis, so on y-axis I am going to taking which one? Rate I am taking. Rate. On x-axis I am going to taking time. On x-axis I am taking time. With respect to time, the rate is always, what is that? Is nothing but constant. The rate is always constant. See, the rate is equals to constant with respect to time. This graph is also number of times they ask. Keep in mind, students. This is x-axis I am taking here. On y-axis rate to x-axis time I am taking. With respect to time, the time is going on. The rate of reaction is constant. With respect to time, rate is constant. With respect to time, concentration of reactants, it will be gives the negative slope. With intercept is equals to initial concentration, slope is equals to minus K. Students, so this is the total information about the integrated rate equation of which order reaction. Zero